Luke, hi, it's great to see you again. Oh, I'm not able to hear you at the minute. You might be on mute somewhere. Brilliant. Do you want to try again?
Yeah, okay. Can you hear me now or no?
Absolutely, yeah. Thank you for that.
Good, all right.
So have you been working on the booth there, Luke?
My first booth duty is actually going to be after this talk and after the rest. So I haven't had a chance to work at it yet.
Oh, well, there you go. You've got to go and see Luke after Tracy Lee later this afternoon. And yeah, go and drop in, say hi to Luke and tell him how great he is working on that booth there. So today you're going to be talking to us about consuming new node observability features in Kubernetes environments. So I'm going to hand over to you now, Luke, and speak to you at the end.
All right. Sounds good. Hello, people on the internet. Thanks for tuning into this talk about consuming observability features in Node.js. Hopefully what I'm presenting here will be useful in your day-to-day, but before we get into the talk, let's just do a brief intro of who I am. Yep, so like as Katie said, my name is Luke Holmquist, or Lucas, if you want to use that as well. I'm a senior software engineer here at Red Hat, where my main focus is on the Node Shift project. This project aims to help developers who are creating Node applications and want to deploy Shift and Kubernetes. This is actually my fourth Node Conf, but only the third time speaking. So just wanted to give a shout out to the friend that I made the last in-person conference in 2019 when they asked me to watch their luggage. So hello to them if they're watching. You can also find me on Twitter at Sienna Luke. And it looked like when I checked just before this, I had 239 followers, which for me, I feel like that's why do I have this many followers? But I think we could probably make it 240. So if you're the 240th person and you come over to the Red Hat booth later, I'll give you a virtual high five. And just a couple of random facts about myself. I'm a huge fan of the band Fish. So if you're also a fan, and that's with a PH, you can find me on Twitter and we can talk some music. And I'm also the current title holder for the Star Wars trivia at my local library, and know entirely too many facts about the original trilogy. So again, if you're a Star Wars nerd like myself, come find me on Twitter and we'll do some talking there. And since we are remote, I'll share where I am located. I live in upstate New York. So if this picture probably might not make sense, given that there might be a good chunk of people from Europe watching this, but if you are watching this from New York, you'll know what I'm talking about with this graphic. So, all right, let's get into this. Okay. So congratulations, you've deployed your application to production, most likely in a container on some sort of container platform like Kubernetes or OpenShift. At the moment, your application is working well, your users are happy, and everything seems to be going pretty well. So now what? How do you keep your application running and running well? How do we keep those users happy? A key part of that now what question is being able to observe what's going on within your application. For example, how many resources is the application using? Is the application calling a function that is blocking Node's event loop, causing users to wait longer than expected? Or is there a REST endpoint that is having intermittent failures? Being able to determine when things are outside the norm will help to keep your application running and your users happy. So with that said, let's take a quick look at what we'll be going over in the talk. First, we're going to take a look at some of the key observability metrics that Node provides natively, as well as some newer additions. Next, we'll take a look at how we can get access to this data when your application is running in production in a Kubernetes environment. After that, we'll take a look at some of the things that you should be collecting. And finally, we'll see a very quick demo of some of the things that we just talked about. But before we get into that, we should define what observability is exactly. According to Wikipedia, it is a measure of how well internal states of a system can be inferred from the knowledge of its external outputs. Well, what does that mean exactly? So in the context of this talk, internal states will be the functions and other business logic that is being executed and processed in our application. And the external outputs are the things that we want to look at or observe to see if everything is running as we expected. So we can rewrite this as a measure of how well our application is running using some metrics that our runtime provides. And with that definition now under our belts, let's see some of the different runtime metrics that Node has to offer natively. And since we know that Node is built on top of V8, not the drink, hold on. Okay, there we go. That's the right image. We can access some of the data as well. Okay, so let's see what's first. Okay, so first up, it's everybody's favorite tool to debug issues with. I know it is mine, console log. Maybe not the greatest for production, but I was tempted not to put this in, but if I didn't, I'm sure somebody on the internet would be like, well, actually, that was me pushing up glasses that I don't wear. You can use console.log. I probably don't need to explain how this works. I'm sure we've all had similar statements like this, whether it's here or why or this actually works. So next up, we have some different ways to do profiling. For those that are new to what profiling is, when talking about coding, a profiler is analysis software that measures frequency and duration of function calls, as well as making sure that those functions are producing the desired result. While there are third-party tools that can be used, Node.js actually has this capability built in since, as I just mentioned, it is built on top of the V8 engine. The V8 profiler allows you to sample the stack at regular intervals during the execution of your application, which get logged as a series of ticks. This can be done on the command line while running your application using the prof flag. This will produce a log file that needs to be processed in order to become useful to look at. It can be processed with the prof_process flag. This is just a sample of a section of what that log output could be. For this particular application, we can see that there is a node crypto function that seems to be taking up a lot of time. With that knowledge, you could go back into your application code and pinpoint what is happening and make the necessary adjustments. In this particular example, which is taken from the guide on profiling, which is on nodejs.org, the code is using the synchronous version of that particular crypto function. Switching to the async version helps clear that bottleneck up. If running with CLI flags isn't your thing and you like to use APIs instead, there's an inspector module inside Node. It is similar to the CLI flags, but you can start and stop the profiler from code. This is an example of how you might do a CPU profile. We require the inspector module, create a new session and connect to it, then enable and start the profiler, do some tasks and stop the profiler. And the file that it outputs can be loaded into the profile section of Chrome DevTools to get a more visual view of what is going on. Next up is trace events. The trace events module provides a mechanism to centralize tracing information generated by V8, Node.js core, and user code. Tracing can be enabled with the trace events category command line flag or by using the trace events module. The trace events categories flag accepts a list of comma separated category names, which allows users to create custom traces by default. The node async hooks, and the V8 categories are enabled. And like the inspector module, running Node with tracing enabled will produce log files that can be opened in the Chrome tracing tab of Chrome. In the example, we are creating a trace for the promise rejections category, which enables capture of trace data, tracking the number of unhandled promise rejections and handle after rejections. There are more categories, so after this talk, I would invite you to take a look at the trace events API docs on Node.js.org to learn some more. Next, we have the perfhooks module. These APIs allow developers to set various markers that make measuring the runtime of an application easier. This module provides an implementation of a subset of the W3C web performance APIs, as well as additional APIs for Node.js specific performance measurements. Node supports the following web performance APIs: high resolution timing, performance timeline, and user timing. With these APIs, you can measure the time it takes the individual dependencies to load and how long your app takes to initially start, as well as determining how well the event loop is being utilized and if your asynchronous code is operating efficiently. Here's a quick example of how you might measure the duration of required operations to load dependencies. It uses the timer5 function, which is part of the performance API. The slide after this one assumes some knowledge of the node event loop. So while we aren't going to go into all of that right now, I just wanted to show this high-level diagram of what it looks like. From a fresh start, new calls come into the poll phase and traverse through the event loop. If we had code that was synchronous, it might block other code from being executed. An important addition to the perfx module is event loop utilization, which was added in the middle of Node 12 and the Node 14 lifecycle, as well as being part of Node 16. The event loop utilization method returns an object that contains the cumulative duration of time the event loop has been both idle and active. ELU is similar to CPU utilization, except that it only measures event loop statistics and not CPU usage. It represents the percentage of time the event loop is spent outside the event loop's provider. For example, the epoll wait thing. No other CPU idle time is taken into consideration. The following is an example of how mostly idle CPU processes will have a high ELU. We're synchronously spawning a sleep timeout, which blocks the event loop. So even though the CPU would be mostly idle, our event loop is blocked, which would slow down our application. So this is a great new addition to be able to determine where a problem might be. And of course, once you're ready to deploy your application to a container-based platform, it becomes a little more difficult to get access to these types of metrics. In this next section, we will talk about getting access to some of that data that I just mentioned when running inside a Kubernetes environment. One of the most production-ready solutions for monitoring containerized applications is the open source Prometheus toolkit. Prometheus is a mature and battle-tested monitoring and alerting tool that provides multiple features as dimensional data that can be identified by metric name and key value pairs, a very powerful and flexible query language so you can merge different metrics together to produce more complex and meaningful ones, multiple modes of graphing and dashboarding, although for this one, you'll have to use a third-party tool like Grafana, for example. And the nice thing about Prometheus is that you can find integration libraries for all sorts of languages and frameworks, which is really nice. One more important detail, Prometheus is pull model. This means that you have to provide the collected metrics somehow, like through an API endpoint or something, so that Prometheus can scrape and collect the desired metrics afterwards. And we'll see a way to automate this in the coming slides. Okay, so how do we expose some of the metrics to Prometheus from Node? We use a library called PromClient that offers a great deal of features. First of all, PromClient can provide by default many of the metrics that I mentioned before, GC metrics, event loop lag metrics, etc. We can, of course, create our own metrics that we want to measure. And one nice thing about PromClient is it allows you to use a push gateway model if necessary. That means we can directly send data to Prometheus without waiting for Prometheus to scrape them. Now, you may be wondering why this is useful. Well, think of the situation where we measure metrics from a batch or background job. Unfortunately, though, the job does not leave enough for Prometheus to scrape the data, but for some reason, we really need to get those metrics to Prometheus. Now, this is where the push gateway comes in handy because the batch or the background job can push the metrics directly to Prometheus right before it finishes. So eventually, Prometheus will get the metrics that we want. In general, we use the push gateway method only on edge case scenarios. So here is a small code snippet of how you require the PromClient module inside your application. This code is basically saying, hey, let me collect all the default metrics that you got. We're also adding a prefix to our metrics, which will help later on when we want to see the metrics for just our application. And a few lines of code later, we expose those metrics in the metrics endpoint. This is a code snippet from the demo that I'll show in a couple minutes. And if we visit that /metrics endpoint that we just saw from our browser, this is what we'll get. Of course, there's more information that is collected, but I'm only showing a small subset since the slides aren't really that big. We can also see that each of the metrics that have been provided have a prefix that we added from that code snippet on the previous slide. If we had more than one application, we can see how the prefix will be useful. I mentioned above that using Prompt Client, we can create custom metrics if we wanted to for our application, but what kind of custom metrics are useful really? Enter red metrics. The red metrics methods defines the 3 key metrics. Well, basically there are 4, but the following 3 are the important ones. You should measure for every microservice in your architecture. Now, these metrics are part of the 4 golden signals series defined by Google Site Reliability Engineering. So basically, a couple of years back, Google published a book based on their experience about what metrics help them maintain their huge infrastructure. These metrics are rate, the number of requests per second your services are serving, errors, the number of fail requests per second, and duration, distributions of the amount of time each request takes. So just by monitoring only these 3 key metrics, you can deduce a lot about how your application performs in general. All right, now it's time for a small demo that was recorded, but which seems that we can't load. So we will just skip that for now. And we'll move on. If we did see the demo, we would see the service monitor that gets added that helps us pull all of our metrics. It's a pretty small YAML file. We have an interval in this spec section. We have an interval that says 30 seconds. So every 30 seconds, we want to scrape the my app endpoint, and that will return the metrics for us. So while this is not actually a built-in Node.js tool, I did want to quickly mention the effort that Red Hat and IBM have started to define what types of things developers could be adding to their application to be the best that they can be. For example, we are in the process of putting together our observability and metrics section. The opinions here are from the experience with the customers that we interact with, and this repo is open for those who would like to collaborate. If you want to find out more, there's a link on nodeshift.dev. And if you watched Beth's presentation yesterday, she went into quite a few things about the reference architecture. So go check out that talk when you can. So as I wrap up here, I hope some of these things we discussed will help in any future applications that you're building. And here are some of the links to learn more about some of the topics that we talked about. And I'll share the slides as soon as we're done with the talk here. And so thank you very much. And also a small Easter egg here. I mentioned that I was a bit of a Star Wars nerd, so a bit of Star Wars trivia. And this was the final question for to win the trivia contest. And it was, what was Princess Leia's cell number in Star Wars: A New Hope? And the answer for that was, I'll give people a minute if they want to write it in chat. All right, the answer for that was 2187, which is actually the same stormtrooper designation for John Boyega's character Finn in A Force Awakens. So it's a nice little nod back to the original trilogy. So thank you very much, and I'll send it back to Katie.
Thank you, Luke. That is a fantastic bit of Star Wars trivia right there. It totally trumps my... I go walking in the Lake District in the UK quite a lot, and it was used as a backdrop for quite a lot of the new Last Jedi film. So I point all that out to the kids, but I've never pointed out things like that 2187. I've never noticed that. So thank you for sharing. So please do let me know if you've got any questions for Luke in the chat channel. But I'm going to kick off with, you talked a little bit about the 4 golden signals for Google. Could you go into that in a little bit more detail? What are the most important things there?
Right, yeah. So I can just click back to that real quick. Yeah, it's the most important ones here are rate, errors, and duration. So you want to know what the number of requests per second your services are serving up. You want to see the number of failed requests that you have per second. And then, the distribution of the amount of time each request takes. So, if you have those 3, then you'll be pretty good.
Yeah, you should be able to, from that, extrapolate all the data that you need.
Right.
Cool. Just trying to see if there's anything more come through, but while we're just waiting for a couple more questions, is there anything else that you can let me know about what Red Hat have been doing and what you're going to be talking about at the booth?
Right. Yeah. So the demo that I wasn't able to show, it was using OpenShift, which is, a flavor of Kubernetes. It's built on top of Kubernetes. And I'm using that because Prometheus is built in, so you don't have to do anything special. And you can just start running your application, and you can add the service monitor, like I had mentioned, and you're ready to go. You don't have to, there's no operators to install. It's all just right out of the box, which is a really great thing. And if you want to, and folks who want to learn more about OpenShift and those kinds of things, definitely check the booth out, and we can talk more about those then.
That sounds brilliant. Okay. I have nothing else for you at the minute, Luke. So I'm going to wave you off, say thank you ever so much for your talk. It was ever so interesting. Really, really great. I'm sorry we didn't get to see the demo, but I'm glad that you're going to get a chance to chat to people about it at the booth. So thank you for your talk, and hope to see you in person next year.
Yeah, that'd be great. Bye-bye.